Welcome back to this second episode about poke interaction. In the previous video, we learned how to poke UI and Interactable, and in this video, we'll see how to use it to create a very nice looking button. So if you are enjoying this video, you know what to do by now. Subscribe, like, and as always, the Patreon is in the description below if you'd like to get access to the source code of all of my videos and more importantly, support my work. Okay, so now let's turn this simple cube into a beautiful button. So first, I'm going to right-click on this cube, create empty parent. This will create, as the name suggests, an empty parent and rename it button. We can select back now the cube and maybe rename it interactable. Perfect. Then we can duplicate it with Ctrl D. And now the reason is that we want to separate the visual of the cube and the collider of this cube. So this way, we'll be able to move the visual independently from the interaction behavior. So let's rename the second cube visual. So for the interactable, let's remove both the cube mesh filter and the mesh renderer. And for the visual cube, let's basically remove everything but these two. Now, by doing so, we now have correctly separated the visual of our cube with its interactable and collider script. But if we go to interactable, then interactable event, we now have lost our reference to the previous mesh renderer. So let's simply drag the visual here and select back mesh renderer material. And now it should remember the color that we wanted to assign previously. There you go. And we can do so for both over and select entered. Finally, I'm going to select the visual game object and duplicate it again. Call it outside. This will be the outside part of the button. We can scale it a bit larger on the XZ axis and a bit smaller on the Y axis. There you go. And I'm going to set another color on this outside part. And just like this, we now have a nice looking button. What's left is to move here the visual part to follow our finger when we press on it. And for this, we are going to make a custom script using the interactable event. So let's select our interactable and click on Add Component. There we go. I'm going to call it button follow visual. Now let's wait just a little bit for this script to compile and open it in Visual Studio. Okay, so first thing first, let's write at the top using Unity Engine.xr.interaction.toolkit. This will allow us to access Unity XR Toolkit component name. Then we are going to need a private XR-based interactable called interactable. There we go. Now at the start of the game, we are going to hook some event to make the button visual follow when we interact with it. So let's do interactable equals getComponent XR-based interactable to access the interactable that is sitting on this game object. And then I'm going to create a function called public void follow. And we can hook this function when we start hovering this button with interactable.overEntered.addListenerFollow. But as you can see, we have now an error here because the follow function needs to have an interaction event argument. So let me just write base interaction event args hover. So in the follow function parameter, of course, and there you go. Now, as you can see, the follow function will be called every time we hover this cube. So what's left is now to enable the following inside this function. But first, we need to make sure that the interactor is in fact a poke interactor and not something else. So let's do if hover.interactorObject is XR poke interactor. And if it is the case, we can get it with XR poke interactor equals parenthesis XR poke interactor over.interactor object. And then I'm going to create a private bool called isFollowing at the top, set it initially to false, but in the follow function that we just made, do isFollowing equals true. Okay, so now that we can trigger the following, it is time to do some math to compute its position. So let me grab Paint to quickly explain you the objective here. So if this is the position of our cube visual and this is the position of our poke, what we want is to place the cube at the position of the poke interactor and add the offset, which is the difference of position between these two. So for this, let's go back to our script. At the top, I'm going to write public transform visual target. This will be the reference of our button visual. And then let's add a private vector3 offset and a private transform called poke attach transform. Now, when we start following, I'm going to set the poke attach transform with poke attach transform equals interactor.attach transform. This gives us the transform that is using the poke, and then compute the offset with offset equals visual target.position minus poke attach transform.position. Perfect. Now let's go in the update function. To move using this offset, I'm going to first check that we are following. So if is following, then do visual target.position equals poke attach transform.position plus offset. There you go. Now let's save. As always, let's reference the variable of our script. So for this, I'm going to simply drag the visual in the visual target here. And there you go. Now let's click on play to try this. And as you can see, it works. When I touch the button, the visual follow my finger. So that's already a good news, but what we want in the case of a button is to, of course, constrain the movement on one axis. So let me leave play mode and go back to our script to show you how to do this. So by the way, this is a great math exercise if you want to know how to only move an object along one axis. And in my case, I'm going to write at the top a new public vector3 variable called local axis. And this is the local axis that the button will use to move. Now the big question is, how do we make the movement only on this axis? And here is a little secret technique that I found in just 2 lines of code. So let's go to our update function. Instead of setting directly the poke and offset to the visual target, let's do vector3 local target position equals visual target dot inverse transform point and give our poke attach transform dot position plus offset. And this will give us the position we wanted if it was a child of the visual target here. But because we have the local position now, we can simply project it on the local axis to get the position constrained on only this local axis. So for this, let's do vector3 constraint local target position equals, yes, that's a long name, so equals vector3 dot project local target position local axis. And simply, now that we have a local projected target position, we can give it back to the visual target as a world coordinate, this time with visual target.position equals visual target.transform point constraint local target position. And that's it. If we save and go back to Unity, let's set the axis to 0, -1, 0, because we want, as before, to go only on the negative y-axis in our case. And if we click on play, as you can see, it works perfectly. The cube now is following our finger, but only on one axis. So now there is basically 2 things that are left to do. Make the button reset when we over-exit, and make the button freeze when we poke select. So let's leave play mode and go back to our script to do this. Okay, so at this point, the hard part of the tutorial is behind us. So this is basically just a little bonus, but what we can do to reset the button is to set the is following to start when we over-exit. What we can do to reset the button is to set the is following to false when we over-exit. For this, let's create a new function called reset that will take a base interaction event args called over. And in the same way as the follow function, if over.interactor object is xrpoke interactor, we can set the is following to false. There you go. Next, we need to hook this function to the interactable as we did previously. So in the start, let's write interactable.overExited.addListener reset. Okay, and finally, let's go in the update function. Now, if we are following, we follow the poke position. Otherwise, let's do visual target.local position equals. And here we need to set the visual target back to an initial position. So we can actually set the initial position to be the one the visual button has at the start of the game. So let's go at the top, add a new parameter called private vector3 initial local pose. And at the start, let's initialize this value with initial local pose equals visual target dot local position. And there it is, now back in the update function. If we are not following, we could do visual target dot local position equals initial position. Now, this is cool and all, but it could be a bit nicer if the button reached its initial position smoothly and not just one time. So for this, there is a well-known technique using lerp that can be done. So at the top, let's add this time another variable called public float reset speed that we can set initially to 5, and down below on the update do visual target.local position equals vector3.lerp visual target.local position initial local pose, then time.delta time multiplied by reset speed. And this is a very interesting line. We are indeed lerping the position smoothly to go to its current position and reach the target position that we have here. So repeat it in the update function. This will give us a nice smooth reset movement. So right now, this concludes the first improvement that we needed with the reset button. Now the next one is to freeze the button when we reach the selected position. And for this one, it's actually really similar. I'm going to create a new private bool variable called freeze, set it initially to false, then create a new function called public void freeze with, as again, with interaction event args over, and I'm going to copy what's inside the reset function and paste it in the freeze function. And instead of setting the is following to false, I'm going to set the freeze to true. Now what's left is to hook this function again to the interactable. So let's do in the start interactable.select enter.add listener freeze. There you go. And now what's left is to go in the update function, and if we freeze, we simply return. So this way, our code will never reach this part and update the position of the visual target if we freeze. And there you go, that's basically it. Now, one last important thing is also to set the freeze back to false when we over exit or enter the button. So in reset, let's write freeze equal false and do the same in follow. So freeze equal fall again. Perfect. And that is it. Now let's save and go back to Unity. And if we click on play, as you can see, it works flawlessly. When I press the visual goes down on the good axis, it freezes when it is selected, so when the cube turns red, and finally, when I over exit, it resets back to its initial position smoothly. And there you go, everything is working well, that's perfect. But there is one last thing that I want to talk about. As you can see, if I reach the button from the other side, the button is moving as well, which we don't want in that case. Now, if we leave play mode, as we can see from the XR poke filter, this is because even if the selection has a poke angle threshold, this threshold is not applied when hovering an object. So the best thing to do is to actually check it as well when we want to move our cube visual. So one last time, let's go back to Visual Studio. Okay, so at the top, let's add again a public float called follow angle threshold and set it to 45 degrees. Now what I'm going to do is in the follow button, we can check the poke angle with float poke angle equals vector3.angle, the offset, so offset, visual target dot transform direction local axis. Then only if poke angle is less than follow angle threshold, we can set the is following to true and the freeze to false. There you go, that's basically it. And now we can once again save, go back to Unity and click on play to try this. And there you go, as you can see, our button is working perfectly and we have now no more issue of reaching it from the other side. This is how to use the poke interactor to make a very simple button with the Unity XR Interaction Toolkit. I hope that you enjoyed this tutorial. As always, you know what to do. You can subscribe and like this video to not miss the next episode about making a wrist menu with this poke system. You can, of course, as always, grab the source code with exclusive content and support also my work on Patreon. This is what is making it possible for me to make those, so a big shout out to my new Patreon. Thank you for watching and see you very soon. Bye bye!